Nodal analysis, which is the part of the circuit analysis. In this video, we are going to discuss about nodal analysis technique. This is one more technique which mainly it's an analysis mainly using the nodes. Nodes is nothing but the junctions, and we apply KCL. And KCL is Kirchhoff's current law. We get some equations, we solve them, we'll use those unknown values to find the remaining parameters of the circuits, right? So let us see our objectives. We are going to define the branch and node, and we are going to identify how many nodes are there in the given circuit, and how to apply KCL, how to write the equations, nodal analysis equations, and how to get the unknown voltages. And finally, we are going to see different varieties of circuits to understand this nodal analysis technique a little more thoroughly. First, we will define what is nodal analysis. And before that, a network is said to be completely solved or analyzed when all voltages and all currents in its different elements are determined, right? So let us define what is meant by branch. Branch is a part of the network which lies between two junctions. So here B AB is a branch, BC is a branch, BD is a branch, right? So it's a part of the network which lies between two junctions. Coming to the next definition, node. Node is a junction in a circuit where two or more circuit elements are connected together, or a node is simply a common junction for two or more components. And here you see here voltage source and resistor, 1 ohm resistor are connected here. This is a node. This is a node. B is a node, C is a node, and D is a node. But among all these four nodes, A, B, C, D, principal nodes are B and D, where a principal node has three or more connections, right? Now, among these principal nodes, we consider one node as the reference node, and we assume that the voltage drop at that particular point, that node is 0, and we assume the voltage drops at the remaining principal nodes with respect to this. Okay, so first principal node, a principal node has three or more connections. Here B and D are the principal nodes, and one among them, it is advisable to consider D as the reference node. It's not wrong in considering B, but we have to redraw the circuit again to get the results a little more comfortably. Coming to this, take the circuit diagram. In this, number of nodes are A, B, C, D, E, F, G, H, and O are the nodes. And among these, principal nodes are A, B, C, D, and O. So among these principal nodes, I am considering O as the reference node, because that reference node should have connection with majority of the principal nodes. Such be the quality of reference node. Coming to the steps involved in the nodal analysis technique. So first you have to identify the number of principal nodes in the given circuit. Consider one among the available principal nodes as reference node. Consider the voltage drop at reference node as 0 volts. So these three, we are aware of them. All this is step number 1. Let us label the remaining principal nodes voltage drops with respect to the reference node as V1, V2, V3, V4, V5, etc. Means with respect to the reference node, the voltage drops at the remaining principal nodes are considered to be V1, V2 and so on, like that. That is step number 2. Let us apply these two steps here in this example. A, B, C, D, E. Among these nodes, B, C, E are the principal nodes. Principal nodes in the given circuit are 3. They are B, C, E. Considering E as the reference node, let us consider the voltage drop at reference node as 0 volts. So we are assuming that the voltage drop at reference node E is 0. Now, with respect to the reference node, the voltage drop at B node B is assumed as V1 and V2 is the voltage drop at node C with respect to E. So these are our assumptions. Step number 2, right? Now, coming to the step number 3, assume the current components with the directions in each branch such as I1, I2, I3, etc. We are going to express these I1, I2, I3 current components as a functions of node voltages, right? So what are we going to do is we are going to assume some current component in branch AB, branch BC, branch BE, whatever the direction it is. But you consider among the current components, one is incoming, at least one is incoming, at least one is outgoing. Rest all the directions, that is your choice. Step 4, we are going to apply KCL at every principal node except the reference node. Then we'll get equations as a functions of V1, V2, V3 and so on. We solve them and we'll get the values of V1, V2, V3 and so on. So using those voltages, you can find the remaining parameters of the network. Okay, so take this example. In this, there are two voltage sources are there. So B, C, E are the reference are the nodes, and E is considered as the reference node. Let I1 be the current in branch AB from A towards B. I2 be the I2 be the current in branch BE. I3 be the current in branch BC. Direction is your wish. It's not compulsory that it should start from B, go towards C only. That is your wish. But among these, at least one should be incoming, one should be outgoing. Remaining things, remaining directions, that they are your wish. See, yeah, see in I4 is the current in branch CE and I5 is the current in branch DC. So these are the next step, right? Now we are going to express I1, I2, I3, I4, I5. They are the current components in various branches which are the functions of V1, V2 and so on, right?